Hello and welcome. Building on our previous session, today's content has been structured to enable you to master the mandatory system cybersecurity regulation IACS UR 27 in under 10 minutes. Let us now proceed to examine each requirement in turn. Secure is your reliable solution for cybersecurity. From new building ships to operating ships, from system suppliers to ship owners, Secure delivers complete cybersecurity solutions. First, please note that the UR-E27 document featured in this video has been prepared based on the sources displayed on screen. Before we proceed, let us first clarify what IACS UR-E27 is. As you can see on the screen, UR-E27 is titled Cyber Resilience of Onboard Systems and Equipment. In other words, UR-E27 constitutes a harmonized set of requirements reflecting the common minimum criteria for delivering systems and equipment with cyber resilience. Now, let's take a look at how the IACS UR27 regulation is structured. The regulation is divided into three parts. Part 1 is called the Introductory part. Part 2 is the main part, which contains the core requirements. Part 3 is the Supplementary part. So, Part 1 is the Introductory part. The Introductory part consists of 5 sections: Introduction, Limitations, Scope of Applicability, Definitions and Abbreviations, and Security Philosophy. We will now examine each section one by one. As you all know, this regulation applies to ships contracted for construction on or after July 1, 2024. UR27 does not address the environmental performance of system hardware, nor does it cover the functional aspects of software. Therefore, UR10 and UR22 must be applied together. UR10 requirements for the environmental performance of system hardware. UR22 equipment requirements for the functional safety of software. Next, let's review the scope of applicability. The ships covered by UR-E27 are the same as those under UR-E26, as explained in the previous video. Please refer to that video for details. As mentioned in the previous video, we will cover the CBS definitions later. In this video, we will skip that section. First, it's essential to understand the security philosophy. So, let's start by looking at systems and equipment. In Clause 2.1.1, a system is defined as the collection of hardware and software that allows a process to operate safely, securely, and reliably. Typical examples include the engine control system and the dynamic positioning system. Equipment can fall into one of the following categories. First, network equipment, such as routers and managed switches. Next, security equipment, like firewalls and intrusion detection systems. Then, computers including workstations and servers. After that, automation devices, for example, programmable logic controllers, PLCs. And finally, virtual machines hosted in the cloud. First, let us look at a typical example of network equipment, the router. In this presentation, we will focus on the MOXA EDR8010. This device is responsible for routing traffic and managing data flow between networks. It is utilized whenever we need to connect the ship's OTIT network to an external network or a port system. Let me introduce a key example of security equipment, the firewall. In this presentation, we will focus on the MOXA EDR9010. This device controls access and inspects traffic from external networks. We deploy it to protect the ship's network from cyber threats and to enforce security policies. Next, let us turn to computers. In this context, computers refers to industrial workstations and servers. Their role is to serve as bridge control consoles, integrating user interfaces such as touchscreens, joysticks, and buttons. They are employed for critical operational control functions, navigation, engine monitoring, and alarm management. Now, let us turn our attention to automation equipment, specifically the PLC. A programmable logic controller, or PLC, is responsible for controlling and monitoring physical processes, pumps, valves, motors, and so on. We employ PLCs to automate the operation of marine equipment, and they serve a critical function within the OT control layer. Lastly, let us turn our attention to cloud-based virtual machines. Their role is to provide virtualized servers and workstations within a cloud environment. They are used for centralized backups, remote management, and data storage and analysis. When it comes to cyber resilience, the requirements laid out in Section 4 apply to every system covered by UR-E26. Any extra rules for interfacing with untrusted networks, however, only kick in for those systems that are actually designed with that kind of connectivity in mind. 2.3.1 Security measures must not reduce system availability. 2.3.2 Controls must not disable safety, control, monitoring, or any other HSE functions. 2.3.3 Systems must support mission-critical operations and guarantee the confidentiality, integrity, and availability CIA of all necessary safety data. In short, security must never impair essential functions and must always preserve the CIA triad. 2.4 Compensating countermeasures. 2.4.1 Compensating countermeasures may be implemented in place of or on top of the security functions built into the original system to satisfy one or more security requirements. These countermeasures must meet the original intent and level of rigor by taking into account any gaps between the reference standard and the actual requirement, and must follow the principles laid out in Section 1 through 3. In other words, if it's difficult to implement the originally required security feature directly, you may deploy an alternative or additional control that delivers the same purpose and effectiveness. But you still have to maintain security at or above the specified level. The second part covers the core requirements of this regulation. Under Section 3.1 on CBS documentation, you'll need to submit 10 specific documents to the Classification Society for their review and approval in order to satisfy the UR's requirements. UR27 defines the security capabilities required for computer-based systems CBS within the scope set out in Section 1.3. The requirements here are built on a subset of controls selected from IEC 624333. To fully grasp each requirement's text, intent, and related guidelines, you'll need to consult the IEC 62433 standard itself. First, you verify the 30 common requirements. Then, for any CBS that communicates with an untrusted network, that is, an external network outside URE26's scope, there are 11 additional security capabilities you must implement. On the screen you're viewing now, you can see the detailed breakdown of each of the 30 common security capabilities. On this screen, you're seeing the specific details for each of the 11 additional security capabilities. And now we've finally reached the last section, the supplementary part. The supplementary part covers the Secure Development Lifecycle (SDLC) and demonstration of compliance. For SDLC, follow a security-focused process through requirements analysis, design, implementation, verification, release, maintenance, and end-of-life. At each stage, document how you've addressed security by integrating the controlled procedures from Sections 5.1, 5.7, then submit this documentation to the Classification Society for review and approval. As you can see on the screen, URE27 lays out the controlled procedures defined in Sections 5.1 through 5.7. In terms of demonstration of compliance, suppliers need to team up with system integrators to assess using Figure 1 whether URE27 must be mandatorily applied to a given CBS. In other words, the supplier and the integrator must jointly decide if a specific piece of equipment or system falls within URE27's scope. The fulfillment of security requirements must be demonstrated according to the workflow shown in Figure 2. This classification process is applied on a ship-by-ship basis, and it culminates in the issuance of a system certificate. In other words, you confirm compliance with the security requirements via the procedure in Figure 2, and then obtain an individual system certificate for each vessel through that process. Plan approval is the review of CBS documentation for a specific vessel. Section 3 documents must be submitted by the supplier to the Classification Society with enough detail to demonstrate UR compliance. If you don't have a type approval certificate, submit the full set of Section 3 documents for plan approval. If you hold a valid type approval, you may submit only a reduced vessel-specific subset. The final approved documents must accompany the CBS when it's delivered. Survey and factory acceptance testing (FAT) are vessel-specific checks required for any CBS lacking type approval. Their goal is to prove by testing or evaluation that the system meets the UR's requirements. You can perform them at your own facility or at an external site with suitable equipment. After plan approval and survey (FAT) are both complete, the Classification Society issues a system certificate, which must be included when delivering the CBS to the system integrator. The detailed survey and FAT activities are outlined from Section 6.31, General Survey Items, through Section 6.3.4, Secure Development Lifecycle. Whether this explanation has been long or short, let's wrap it up. IACS UR E27 is a unified set of requirements that captures the common minimum security capabilities needed to ensure cyber resilience for systems and devices installed on board ships. That was Understanding IACS UR E27 in 10 minutes. Next time, we'll dive into what CBS computer-based systems are. Shawnette is always here for you to reduce the potential cyber threats you may face. Explore our comprehensive connected solutions by scanning the QR code below for additional detailed information. Thank you for joining us today, and we look forward to supporting your cyber resilience journey. Please subscribe to our channel and hit the like button to access more high-quality educational videos and stay updated on our latest training sessions.